guys, I hope you're doing great today. Well, we have covered the basics of Terraform so far. So we started with what is Terraform and how Terraform works. We also provision VMs and storage buckets on Azure and GCP. And after that, we covered about Terraform state file and state locking. So I've also created a 4 hours beginner's course, you can say, on Terraform, so you can watch it on my YouTube channel, DevOps Molvi. So I thought we should now cover the important interview questions and answers regarding Terraform. And you can see the thumbnail. I have this thumbnail, what is Terraform module? And honestly, that was the question that has been asked in one of my DevOps interviews. What are Terraform modules? So I have collected really important 50 Terraform interview questions with their answers. So let's discuss them one by one. And if you prepare these questions, I hope that you will feel really confident about Terraform. Okay, we have covered almost every concept in my previous Terraform videos. So if you have watched all those videos, or if you have watched the 4 hours on Terraform course video, I hope that you will be able to answer each one of the questions. So without any further ado, let's get started. Slideshow and Terraform interview questions and answers. Question number 1. What is, guys, there are other questions that I have skipped, but you can expect, like what is Terraform, how Terraform works. So these are actually very basic questions. So I have not included those really basic questions because you can, you obviously you know what is Terraform and how Terraform works. I have collected the most suitable and the most frequently asked Terraform questions, whether you are a beginner or a professional. So what is the Terraform state file and why is it important? Okay, terraform.tf state file. You know, when we run terraform init command and we get a Terraform hidden directory, and when we run terraform plan, we get the whole plan of our infrastructure in a JSON file. But when we run terraform apply, our infrastructure is provisioned and we get a terraform.tf state file and a terraform.tf state.backup file. So what is Terraform state file? The Terraform state file is a JSON, okay, or binary file that stores the current state of the managed infrastructure. It records resource metadata, dependencies, and other relevant information. So terraform.tf state file, in short, has everything, every information about our infrastructure that has been provisioned by Terraform. And the state file is critical for Terraform's operation, as it allows the tool to understand the existing infrastructure and track changes over time. So let's suppose I have 5 virtual machines that have been provisioned by Terraform, and when I'm going to add 5 more VMs, Terraform will obviously look at the Terraform state file and it will say that we have 5 VMs already. I have to just provision more 5 VMs. So that is why Terraform state file is literally so important, that it is really hard to manage Terraform without a state file. So that is the importance of Terraform state file, and it is generated automatically when we run Terraform apply. What is the purpose of Terraform plan command? You know, these are the most frequently used Terraform commands, like Terraform init, plan, validate, fmt, and destroy, Terraform apply. So one of the command is that we run after Terraform init is Terraform plan. And the plan command provides a summary of the actions Terraform will take, such as creating, modifying, and deleting resources. Terraform plan does not create the resources. It will just give an overview that you as a DevOps Engineer has a quick overview of the infrastructure that Terraform will provision for you. And when we run Terraform apply, it gets starting creating. You know that. And it allows you to review and verify the changes before applying them to the infrastructure. So Terraform apply in a Terraform plan, is an overview in a JSON format in which we get the whole detail of our Terraform infrastructure that is going to be provisioned for us. It contains the details of virtual machines, blob containers, storage buckets, and also about the storage accounts, so on. So Terraform plan, we run it after Terraform init. What are Terraform variables? Question number 3. And how can you use them in your infrastructure code? We have Terraform variables, right? And we have Terraform variables.tf file. Variables.tf file, we have used it in one of our labs, and we also have used terraform.tfvars. Okay, that question is also coming. So what is variable? What are Terraform variables and how we can use them? The purpose of Terraform variable is to declare a variable and use it multiple times in our configuration files. That is actually the basic concept of using variables. Variables are not limited to Terraform only, right? We can use them in our Linux scripts. We can use them in our programming, coding. So in Terraform, variables allow us to parameterize our infrastructure code and make it more reusable and configurable. Okay, and variables can be defined in Terraform configuration files like variables.tf or separate variable files. So we can use variables to customize resource configuration, such as specifying the number of instances or setting environment specific values like zone, the storage type, or a resource group. So for instance, I have a resource group, I can create a variable for it, and that variable can be used multiple times in multiple Terraform configurations. Even if we are using Terraform modules, then these variables are literally important. If I have 10 or 20 different configuration files, I can have a single variables.tf file and I can use those variables in multiple Terraform configuration files. So that is actually the purpose of using Terraform variables. Question number 4. What is a Terraform backend? That is actually one of the most important Terraform questions. Terraform backend. And it is the ability to safely store your state file. So Terraform knows which changes have been applied already and which will be applied when you need to run your code again. So we have two types of backends, by the way. I have this question as well. So Terraform backend is actually a place where terraform.tf state file is stored. And that terraform.tf state file contains the information about infrastructure, our infrastructure. If we modify, if we change, Terraform will definitely look at our state file. And if we have a state file locally, it will obviously look at our local backend. If we have a Terraform state file on a remote location, like we had in a blob container on Azure or a storage bucket in GCP, so Terraform will look at the backends, and this is actually the place where we store our Terraform state file. And Terraform backend knows where do I have to check the Terraform state, and when we have any modifications, then that state file is also updated accordingly. If new infrastructure is being provisioned, it means that we will have a new version of Terraform state file. So that is actually Terraform backend. We have two types. Let's discuss them two in our question number 5. And those types are: 1, local backend. The number 2 is remote backend. And now differentiate question number 6. So these are actually regarding related to Terraform backends. What is the difference between local and remote backend? The difference is literally so simple that local backend, as the name says, where the state file is stored on our local file system. If it is a virtual machine, Ubuntu, and I don't have a remote location, I can have state file on my local VM. But it is for my personal testing. If I am the only guy who is managing infrastructure, then I can have my local state file on my local machine. But in case there are 10 or 20 DevOps engineers teams and they all have to manage the infrastructure, then we should have our Terraform state file on a location that should be remote and can be accessed by all the DevOps engineers. And that is actually remote backend, where the state file is stored in some remote file system or storage like Blob container or a storage bucket or S3 bucket on AWS. So that is actually the difference. Question number 7. How can we configure a custom local backend? And we have a custom local backend. By the way, when we run Terraform apply command, a Terraform state file is created on that location. But I want to have a separate location that is dedicated for that state file. Then we can customize our local backend and we can have our Terraform state file in a custom directory using the following configuration. That is actually the configuration for our custom local backend. Backend should be local, and this is actually our workspace directory where we are going to contain our Terraform state files, and this would be our path. So for instance, I have the state files for dev, prod, QA. Then I can have different paths like in the same workspace. So this would be the main directory, and this directory will contain the state file for dev. We can have another path as prod terraform.tf state file. We can have another path like QA / terraform.tf state file. So that is actually a custom local backend, and we can configure it look for our local virtual machine. So this is actually the code that you must know, and this is really simple. This local backend is actually used to configure our local backend, and we can have our custom workspace directories and paths to have our state files on a custom location on our local virtual machine. Question number 8. What are the advantages of using remote backend in Terraform? Now we have discussed about local backend. And now why do we need Terraform remote backend? What are the benefits of using remote backends? And the answer is remote backends provide better scalability, collaboration, support, and durability, making them more suitable for managing infrastructure at scale in production environments. It is obvious that in a production environment where we are working as a team of DevOps engineers, we must have a remote location to have our Terraform state file. So these are a couple of benefits of having remote backend. And guys, by the way, while working on Terraform at large scale, we must have a remote backend so that we can collaborate with our team members. We can have our scalable infrastructure, and we can configure and maintain our infrastructure with a remote backend. And these are actually the key benefits of having a remote backend. Question number 9. What resources do we need to have a Terraform remote backend on Azure? Actually, it is from one of my labs that we did actually practically on Azure, and we need a resource group, storage account, and a blob container. Blob container means a storage bucket like we have on AWS S3. So blob container is actually the point where we will store our Terraform.tf state file. So these are actually the prerequisites, resource group, and a storage account. and then we will have a blob container that will actually store our Terraform state file on a remote backend on Azure. Question number 10. What is a provider in Terraform? Like Azure M is a provider on Azure. What is a provider actually? And it contains, by the way, provider is a plugin which enables interaction with an API. And it is the man in the middle, okay? So it also talks to the remote, the provider that we have on our registries, and Terraform uses that provider to build resources on our cloud platforms. So for instance, if we have Azure, we must have to use the Azure M provider. If we are using GCP, we can use Google as the provider. If we are using AWS, we have to use the AWS provider. So each cloud platform has a provider, and it contains the APIs that are used to call to provision our infrastructure. And the provider is specified in the Terraform configuration code provider.tf, in which we explicitly mention what is the provider we are using in our Terraform configuration. So if you have watched my Azure labs and GCP labs, you saw that we have been using Azure M as our provider. So it means that Azure M provider contains all the APIs that are needed to provision resources on Azure cloud. Okay, so it is actually a bundle of APIs, a provider that has been provided by all the cloud platforms, so that we can use these providers to provision infrastructure. And these are actually, the providers are actually used as API calls. So what are we going to provision? That provider actually helps to know to the cloud platform that these are API calls. The Terraform configuration file has the resources, virtual machines, blob containers, and those are provisioned using the API call. So if we are not mentioning the provider in our Terraform configuration file, we cannot build infrastructure on that cloud platform. I hope that now you understand. This is the main purpose of having Terraform provider. Question number 10. What is the purpose of the Terraform init command? So when we have our Terraform configurations ready, we run Terraform init, okay? And this command actually initializes a Terraform working directory, and it downloads and installs the necessary provider plugins. So we have to give the provider Azure M, like Azure M as our provider. So Terraform will use this provider to download the plugins and sets up the backend configuration, whether we have local or remote backend, and prepares the directory for Terraform operations. So when you run Terraform init command, it prints out a lot of output that it is initializing the backend, initializing the configuration. We have .terraform hidden directory, we have Terraform state log file .hcl hidden file. So everything is set up and we are getting ready to provision our infrastructure. So this is the purpose of Terraform init, to initialize an empty directory when we run Terraform init. So Terraform init command actually initializes a Terraform working directory. Question number 12. Can we manage an infrastructure without a provider? If we don't have a provider, and the answer is no. We cannot manage any infrastructure, even a single VM, without a provider using Terraform. Okay, without provider, we don't have the API calls and how we can provision infrastructure. So without a provider, we cannot have our infrastructure. What is the Terraform registry? So these are also related questions, and Terraform registry is the main source for publicly available Terraform providers. I have shown you on registry.terraform, that was the website where we have our all providers and that registry contains the providers that are officially verified by HashiCorp Terraform, and it offers a browsable and searchable interface for finding providers. We can find other providers as well. So that is actually the Terraform registry. It is just like we have a Docker registry, okay, where all the Docker images are stored, and we can search Docker images of our own choice that we want to use in our Docker files. So similarly, Terraform registry is a place where it contains the providers, and we can search those providers on that official registry site. Question number 14. What is the core purpose of Terraform registry? Why should we have a Terraform registry? And the core purpose of registry is to serve as a central hub for individuals and organizations looking to publish, discover, and use Terraform modules and providers to automate their infrastructure. So it is a central point where we have our Terraform modules and providers so that they can be used by other people, DevOps engineers and automation engineers, and it is the central hub for organization where they can publish and they can discover and use Terraform modules. So this is actually the purpose of Terraform registry. Question number 15. What is the Terraform modules? That is also one of the important questions. A Terraform module is a set of Terraform configuration files in a single directory. Like we did in our Terraform modules lectures, we had 3 virtual machines and we had 3 directories with their Terraform configuration files, and they were treated as child modules, and we had a root module. So if we have a simple single .tf file, .terraform configuration file in one directory, then it is a Terraform module. Okay, I have mentioned it. Even a simple configuration consisting of a single directory with one or more .tf files is a modules. So you can watch my Terraform modules lecture, and I have explained in detail what are modules and how modules work. So this is actually the definition of Terraform module. Explain using the terraform.tfvars file for variable assignment. So we have variables.tf where we actually declare those variables, but from where those variables will get the values, this is actually terraform.tfvars file, and it is used to assign values to variables declared within Terraform configurations. Okay, we declare variables in variables.tf file, sir, but when we have to give them specific values, we can create terraform.tfvars file, and we can mention the values for those variables in this file. And instead of defining variables directly within the configuration files, this is actually a great approach in which we can organize large infrastructure. It is to organize large infrastructure, and we can have terraform.tfvars file where we can assign the values to those variables. And this is I think our third lab in which I have provisioned infrastructure on Google Cloud platforms, and I have used this approach where we have variables.tf and we have terraform.tfvars file. So this is also discussed in detail in that lecture. So Terraform automatically reads terraform.tfvars files and variables.tf files to automatically load those variables. Question number 17. What is the use of Terraform modules? Why do we need Terraform modules if we can straightforward provision our infrastructure? But why Terraform modules? And we can significantly reduce the amount of code we need to write and maintain. Rather than repeating the same code, we can create a module. Okay, and modules are, you can say that the code snippets that can be reused again and again. Instead of writing new code for everything in our infrastructure like virtual machines or storage buckets, we can create specific modules and we can reuse them again and again and again instead of writing new code. So this is the main purpose of having Terraform modules. Rather than repeating the same code, we can create a module and we can reference it multiple times with different parameters. So that is the main purpose and use of Terraform modules, and it reduces the time and reduces our effort to write the same code again and again. Question number 18. What is terraform.tfstate.backup file? We have terraform.tfstate file, but we have another terraform.tfstate.backup file, and this is actually the backup of terraform.tfstate file. That is simple. Okay, we have a state file and that backup file is the backup of that state file, and Terraform automatically creates the backup of the state file before making any changes to the state file. And in case of any disaster or corruption, we can recover our terraform.tfstate file from that backup file. So this is also one of the beautiful things of Terraform. It automatically creates a state file and a state backup file. In case of any disaster or corruption, we can restore the state file using that backup file. Question number 19. In what cases can we use terraform.tfstate.backup file? So I have explained it in more detail here. So there are actually the three use cases in which we can use this backup file. If our terraform.tfstate file is corrupted or accidentally deleted. If I have accidentally deleted or removed my main terraform.tfstate file, then I can use this backup file to restore my state file. Number 2, if we accidentally delete a resource from our Terraform management and I don't have any clear idea which resource I have deleted, so I can also create the new state file again using this backup state file, and then we can reprovision. So number 3, if we need to revert to a previous version of infrastructure for some reasons, if there are anything that is not working as per our expectations and I want to revert to my, for instance, if I have upgraded a couple of virtual machines using Terraform, but those upgraded virtual machines are not working as per my expectations, so I want to downgrade them back to their state. So then I can use this backup file and we will have again the virtual machines that were in the previous or earlier state. So these are actually the use cases where we can use the backup.terraform.tfstate file. Okay. Question number 20. So how can we use terraform.tfstate.backup file to restore our Terraform state? Mention the steps, please. Okay. So you know that you can restore your backup state. And what should be the steps to restore our Terraform state file using the backup file? So there are actually 4 steps. Number 1. First of all, we have to remove the terraform.tfstate file. After all, it is corrupt or no longer beneficial for us. So either we can remove the current state file or we can move it to some other temporary directory. And then we can rename this backup file to this tfstate file. Number 2, we can run terraform init command and then apply command. And after that, Terraform will compare the current state of our infrastructure with this renamed state file, and it will make the necessary changes to bring our infrastructure back into line with this current state file. So that's how we can recover our original infrastructure that was working before the loss, before the corruption of our state file. So these are actually the straightforward step. We take the copy, we will rename, and then we run terraform init and apply command, and we will have our infrastructure back. Question number 21. Please share the best practices for managing Terraform state backups. Okay, so after all, when our infrastructure is in production, we have to be very careful. So what are the best practices to have our safe and secure Terraform state backups? And there are 3 steps or 3 practices that I have mentioned here. Number 1, store the terraform.tfstate.backup file in a separate location, okay, from the terraform.tfstate file. This is one of the best practices, that both files should not be in the same directory. This will help to protect the backup file from being corrupted or lost along with the state file. And this will be a disaster if we lose both files. If we lose the state file and the backup file, then it will be a huge disaster. Okay, so make sure that we have a separate location for our state file, and we have a separate path or directory. You can see you have gone through the local backend, how we can have a custom local backend. This is actually the real use of having a custom local backend, so that we can have a separate location for our state file and a separate path or location for our backup state file. So in case of losing the state file, we can easily recover our state file using the backup file. Number 2, backup the terraform.tfstate.backup file. We have to back up this file again to our backups, and this will ensure that we have a recent backup of our state file in case something goes wrong. So these are actually the necessary steps to be on the safe side if we accidentally lose our Terraform state files or backup files. Number 3, test the Terraform state backups regularly. This will ensure that we can successfully restore your state file from a backup if we need it. So we have to test our backup state file on our dev or on our local environment, so that we are sure that the state file and the backup files are working properly. In case of any disaster, what if the backup file is not working? Then what is actually the benefit of having that backup file? So we have to check regularly whether this backup file is working or not. So these are actually the measures and the best practices for managing our Terraform state backups. Okay, and these are actually observed in large or IT organizations where our infrastructure is running on production. Question number 22. What is Terraform apply command used for? We have discussed Terraform init, plan, and now apply. So the Terraform apply command executes planned actions, creating, updating, or deleting infrastructure resources. So we actually create or update or modify or delete our resources using Terraform apply, and resources to match the new state outlined in our infrastructure as code. If I update main.tf file, I have to run Terraform apply command so that it actually applies the changes to our infrastructure. And before making, like I said, before making any real changes to the infrastructure, Terraform apply provides an execution plan for reviewing the changes, ensuring transparency and control. We run Terraform plan, but when we have to actually provision our infrastructure on cloud platforms, then we have to run Terraform apply, and it will create, update, or modify our resources. So if you have watched my labs, we have tremendously used this Terraform apply command again and again and again. Okay. Question number 23. What are the best practices for managing Terraform state? We have discussed Terraform State Backup, and the practices are almost the same using if we want to manage our terraform.tf state file. Number one, we must have terraform.tf state file in a shared location, like in a blob container, where our whole team can access it. We must use a Terraform state backend to manage the state file in a remote location, such as cloud storage bucket or Terraform Cloud. We must back up the terraform.tf state file regularly, and must use the terraform state command to manage the state file directly onto only when necessary. So these are actually the same steps that we had discussed for our backups terraform state backup file. So these steps are practices you must know as a DevOps engineer to manage our terraform state file. And that is why I told you in our earlier questions, remote backend is preferred when we are working in an IT organization, when we have our infrastructure in production. So we must have our state file on any cloud platform or Terraform Cloud or Azure, so that every member of our team can manage this file. Question number 24. What is state locking in Terraform? We have discussed in our videos, but again, to revise our concept, what is state locking? And state locking in Terraform will lock our state for all operations that could write the state. And this prevents others from acquiring the log and potentially corrupting the state. Okay, when there is a team of 10 or 20 DevOps engineers, if someone is working on provisioning any change on the infrastructure, the Terraform will lock the state so that none of the other team members can use Terraform at this moment, because it is being used by one DevOps engineer. So that is actually the core purpose of using state locking. Terraform will lock the door and no one can enter, and no one can provision or change or modify the infrastructure using Terraform, because the state has been locked. Okay, just like we lock the door and no one can go out or in. So the same you can say use the same concept in state locking. So no one can modify or provision new infrastructure or change or update or delete when someone is working on our Terraform using Terraform apply command. So the state is actually locked, and this is known as state locking in Terraform. What is the difference between Terraform log file and a state file? So we have two files. One is hidden .terraform.hcl. Okay, this is actually a hidden file, and there is a state file, terraform.tf state file. So if you want to see the log file, you can run ls-la command, and you can see the hidden .terraform directory and hidden log terraform log file. And this Terraform state file contains the actual infrastructure data, right? We have everything in our state file. However, the log file is a temporary mechanism to manage safe access to that data, and that log file is used for state locking, so that the access to that data is in safe hands. That is actually an important concept from security point of view, and having a Terraform log file will actually manage the safe access to that data. And where we have that data, we have it in terraform.tf state file. Question number 26. How Terraform log file differs from Terraform configuration files. We have Terraform configuration files like main.tf, variables.tf, provider.tf. So these are actually Terraform configuration files. But we have a Terraform log file, and there is a huge difference. What is that difference? The log file is not the part of Terraform configuration itself. So it does not have the .tf ending. Okay, it does not have a .tf ending, and However, it does use the same language as Terraform, the HashiCorp configuration language (HCL). Hence, the log file has the file ending like .hcl. Okay, terraform.lock.hcl. This is actually the log file, and at a high level, the Terraform log file ensures that the same provider version is used across different systems and different Terraform runs. Okay, this log file actually contains the provider version, and that provider version is used for every when we have to provision the infrastructure and when we have to run Terraform commands. That specific version which is in the Terraform log file is used for all our Terraform commands. So this is actually the key difference. So question number 27, explain the command terraform validate in the context of Terraform. You guys know that we have different commands like terraform init, plan, fmt, destroy. So we have a terraform validate command as well, which examines the configuration files. It checks out all the configuration files in a directory, concentrating solely on the configuration and ignoring any external services such as remote state providers, APIs, and so on. It checks out the validity of our configuration files. And Terraform validate in short tells us about the syntax errors or if there are any syntax issues. So it determines that from syntax point of view our files are correct, and it does not care about the variables or the current states. So the files should not have any syntax errors, so we can run terraform validate command. Question number 28, explain the workflow of the core Terraform. So what is the workflow? We have 3 steps. We know these steps. Okay, we write Terraform files, configuration files. So it is the first step. We plan our infrastructure, plan ahead of the time to see how the changes will look before they are implemented. And we run Terraform apply to have our infrastructure built on our cloud platforms. Question number 29. What are the most useful Terraform commands? So it is a simple but most frequently asked Terraform interview question. We have these most frequently used Terraform commands and very useful: Terraform init to initialize the current directory, Terraform refresh refreshes the state, Terraform output views Terraform outputs, Terraform apply applies the Terraform code and builds the stuff, and Terraform destroy what has been built by Terraform. Terraform graph creates a dot formatted graph, and Terraform plan a dry run to see what Terraform will do. Okay, so these are most frequently used Terraform commands. By the way, I have not used Terraform graph so far, so I will definitely try it and share how does this command would work. Question number 30. What is the purpose of Terraform refresh command and when would you use it? And the answer is Terraform refresh command retrieves the current state of the infrastructure resources and updates the Terraform state file to match the real world resources. It is also useful when changes have been made outside of Terraform's control and the state file needs to be updated to accurately reflect the actual state of the infrastructure. Okay, what is the current state? So we can run Terraform refresh and it will actually updates the state file to match the real world resources. Okay, question number 31. If we have created different modules like VPC, EC2, security group, access key, and subnet, so how Terraform will get an idea of which resources should deploy first? There are actually dependencies among the resources. So Terraform is intelligent enough to classify which resource should be built first. So yes, Terraform automatically figures out the dependency graph based on the resource reference in our code. It understands the relationships between resources and it uses this information to determine the order in which the resources should be created or modified. So Terraform does this on autopilot, and it automatically checks the dependencies, the orders of the resources, and it builds those resources first that the others resources depend on. So you so that is why so everything is automatically figured out by Terraform. Question number 32. How do you manage secrets and sensitive data in Terraform? This is actually the most common question, but very important question, whether you are having a Docker interview, having a Git, CI/CD, Ansible, Terraform, or Kubernetes. So we can expect this question for all the tools, for all the platforms. Okay, how we can manage our secrets in Ansible, how we can manage our secrets in Docker Compose. So how we can manage our secrets and sensitive data in Terraform. So we have these 6 practices. We can use HashiCorp Vault, just like we have Ansible Vault, okay. So we have HashiCorp Vault. So it is actually a secure digital vault for all our sensitive information like passwords, API keys, encryption certificates. We have everything in our HashiCorp Vault. And also the recommended practice is to store secrets outside Terraform code. We should not use hard-coded secrets, and we must avoid storing secrets directly in our Terraform files. It is totally not recommended. We should not have any hard-coded secrets in our Terraform configuration files. Store states remotely, encrypt sensitive data. Number 5, avoid plain text secrets. And number 6, secure access to the states. So these are the steps to manage and store our sensitive data and secrets in Terraform. What would be the command to initialize Terraform directory without plugins? I don't want to initialize the plugins again and again, so I can use this switch. Get plugins is equal to false when running Terraform init, and it will initialize the directory without plugins. So this is actually the key switch that you must know. Question number 34. What is the Terraform command to apply changes without being prompted to enter yes? When we run Terraform apply, we have to enter yes before it actually starts provisioning the infrastructure. But I don't want to write yes, and this would be, I have used this command in one of the recent lectures. We can use auto approve, and we don't have to write yes. Question number 35. How would I modify the Terraform command to apply changes to a specific target? I don't want to touch the rest of the resources, the rest of the infrastructure. I just want to change or apply the changes to a specific target. Then I have to mention this target in Terraform apply command. Terraform apply, and this is, for instance, my target, my EC2 VM, and I am downgrading or upgrading it. So I just want to apply changes to this. Instead of running Terraform apply all over again, I can just apply to a specific target, and this Terraform apply will update or modify this specific target. So that's how we can mention that target. Okay. Question number 36. What would be the Terraform command to log the Terraform state manually? By the way, it is actually done automatically, but if I want to log the state file, then this is the command terraform apply log is equal to true, and it will log the state file, so it cannot be modified by other Terraform apply or modification action. Possible only where backend allows locking. Okay, when we have a remote backend and we have enabled state locking, so this command can be used. Terraform apply log is equal to true, and if we don't want to have it manually, then we can use log is equal to false. Question number 37, what are Terraform workspaces? Okay, so workspaces help us to isolate independent deployments of the same Terraform configuration while using the same state file. And there is another definition of Terraform workspaces: to let DevOps teams manage configurations for different environments in a centralized way. So we can have the same state file, but we can have different workspaces like dev, prod, QA, sandbox, and that's how the same configuration files are used for to isolate the independent deployments. So we can use Terraform workspaces. And now I hope that you will have a clear picture of why should we have Terraform workspaces with a dev or prod environment scenario. So this is a real-time scenario, and let's say we want to deploy our Terraform code to both dev and prod environments. We have two infrastructures. We have dev, we have prod, and we have the same state file. So we can use workspaces to manage these environments separately. Now, I hope that you have an understanding of why we should have workspaces, because we can deploy our Terraform code to both environments, and that's why we can have a different dev workspace, a different new prod workspace. That's how we can have our workspaces, and we can select the Terraform workspace to deploy code. For instance, if I want to deploy my code to the dev workspace, then Terraform workspace select dev, and for prod it would be Terraform workspace select prod. So that's how we can have different workspaces, and we can deploy Terraform code to different environments. Question number 39, what is the provider block in Terraform configuration? I'm not sure if such questions are asked on an on-site interview, but you can expect these interview questions and answers when you are having an online technical interview. So if the interviewer asks us that we have this block, provider block, why we should have this block? So the answer is the provider block specifies the provider. Now we can specify this is our provider, Azure M, and it will use to interact with our cloud or service infrastructure, and how we are giving the credentials here, and it includes configuration settings for the providers, and such as authentication credentials and region settings. Now we have used Azure M provider a lot in our labs. So you can see I have the authentication settings given in this. By the way, this is not a recommended practice since I have used the hard-coded or plain text subscription ID and other passwords. But this is how a provider block looks. We have a provider configuration and authentication credentials. So this is actually the block where we give the information about our provider. It can be like GCP, it can be Google or AWS. Question number 40. What is the resource block in Terraform configuration? Okay, now it is also a remote job interview question, and that is why I'm explicitly mentioning these are actually, you can expect these questions in your remote job interview. So the resource block, I have also given the example in which we are having a virtual network. This is our resource, okay, and we have defined it in a resource block. We can have firewall rule, we can have a private subnet, we can have a virtual machine, we can have a blob container. All these are resources, and the resource block defines the infrastructure components you want to manage. Each resource block specify a resource type, a name, and it along with its configuration parameters. So this is actually a full resource block for creating a virtual network. You can see we have the name. This is actually hard coded. I'm not using any variables. Address space location. Now these are actually variables. Location, resource group name, and it will create a resource, a virtual network. So this is the example of a resource block. Now question number 41, explain the whole block line by line. Remote job interview question. Now this is actually a block in Terraform configuration that I've taken from, and I have been given this block and I have to explain what each piece of code is doing. So first we have network interface, and this specific block of code is part of the configuration for setting up the networking of a GCP instance. We will have a network attached to that GCP cloud, Google Cloud Platform instance, and network is equal to Google Compute Network dot VPC underscore network dot name, and this line will specify the VPC network. This line of code is actually telling us that our compute instance will be attached to this network. And the final piece of code is access config. Automatically it will enable public internet access for the VM by assigning it an ephemeral public IP address. So guys, this is actually a preparation of mine that you can expect such questions. You can be given a piece of code of Terraform resource block or provider block, and you're asked that what's going on here, just like we have a normal coding interview, that what is the output of that piece of code. So you can expect that what is the output. So that is why I have mentioned such questions, that it is just the preparation, that you must have clear concept that what that specific configuration, that specific code is doing. So this is just as an example. By the way, you can find this detailed. I have a main.tf file with all the comments that each line is provisioning, what is the purpose of each line. So I will definitely write it in the description. By the way, we have Terraform DevOps Molvi GitHub repository where I have tried my best to write the comments of each block and each line, that what is that code or what is that line doing for our infrastructure. So this is just the preparation of your mind. I don't want to overwhelm you with these tough questions, but you can expect, okay, especially when you are having a technical remote job interview. Question number 42, if someone changes main.tf or adds any additional file and you want to reflect those changes, how would you do that? And this is actually the command. I have used this reconfigure, and we can run Terraform init reconfigure to reflect the changes that have been done in main.tf. Question number 43, what's happening in the following code? Okay, again, and you can see we are having a blob container, okay, and it will have a storage account, and the access type of that blob container is private, and it will be used to store our Terraform state file, and the name of this blob container is tf state. Okay, so if you can learn the blocks for a couple of resources, it would be easy for us, for you and me, to define or to explain what's going on in that specific code block. Question number 44, what's happening in the following code? And now we are configuring a remote backend. Okay, this is actually Azure M remote backend. It will configure, create a new remote backend on Azure to store our Terraform state file, and this is actually the storage account name, this is the storage resource group, and this would be the container blob name, blob container, where we will have our terraform.tf state file. What's happening in the following code? Now you can see we have this admin SSH key, username is DevOps Molvi, and public key is the path of the public key. We are explicitly mentioning the username and SSH keys in our Terraform configuration file. And these credentials will be used to SSH the virtual machine that we are provisioning. So we can let Terraform know that you have to use this public key to provision that VM. So we can use private and public key pair to SSH our VM. Make sure that we must have the public key file on that location. All right. What's happening in the following code? And it is also a remote job interview question, and this is actually regarding Terraform modules. We have two modules, child modules, VM1, VM2 with their configuration files. This would be our root module where we are going to run our Terraform commands. Since there are two modules, VM1 and VM2, so it is obvious that it will be used to spin up two new virtual machines. Can we delete the default workspace in Terraform? And the answer is no. We cannot delete the default workspace. Question number 48. Now some easy questions to wind up our Terraform interview questions and answers. In which language we get the output of Terraform plan? I hope that you know it. It is JSON. Okay, we have the output in JSON format, JSON language. Question number 49, second last question. You have worked a lot with .tf files. So which language are they written in? And it can be important. The Terraform .tf configuration files are written in HCL, HashiCorp configuration language, and I have told it in our What is Terraform lecture. So HCL is the language in which Terraform configuration files are written. And our last question, question number 50. Why would you choose Terraform? You can answer it according to your taste. So why should you choose Terraform? I would choose Terraform for its ability to streamline infrastructure provisioning. Okay, the main purpose is to provision infrastructure, and I can manage my infrastructure through code, and I can ensure consistency and reducing human error. So that is the reason I would choose Terraform. And guys, by the way, we will have more on Terraform in our upcoming lectures as well. Terraform is not ended yet. There would be more stuff like Terraform workspaces. We will definitely cover in our upcoming lectures. And that was the last question. And I really thank you for your time. And I would really appreciate that if you subscribe DevOps Molvi. And if you have any confusion in any of the questions, you can ask me in the comments. And also, if you are still confused how all the stuff works, I have created a 4 hours lecture, a 4 hours Terraform course for beginners that you can find in the description of that course link. And make sure that you watch this course first, and then you can I'm pretty sure that you would be able to answer almost all of these questions except the questions related to Terraform workspaces. I'm just preparing your mind that we are going to cover up in our Terraform upcoming lectures. So make sure that you hit the like button, share it among your friends, and make sure to subscribe DevOps Molvi. I really need your support, and I appreciate it. The support that you have given me so far. I have been receiving messages on Instagram and on LinkedIn, appreciating the work that I have done so far. I will talk to you in the next video. Have a good one, and bye.